In problem 8, we're asked to solve the system, and in looking at the equations, I noticed that 2x plus 4y is equal to negative 4 is in standard form, as well as 3x and 5y is equal to negative 3. The x's are lined up, the y's are lined up, and so are the known numbers. So it is set up for elimination, but looking at the x coefficients and the y coefficients, I notice that there is no single number, whole number, or integer that I can multiply by that will make a zero pair. So I need to now use double multiplication. And I made either zero pair the x or the y. I choose to do x this time around. And in the case of double multiplication, it's very easy to do by doing the coefficient of one times the coefficient of the other. So 2 gets multiplied by 3 all the way across. Create an equivalent equation. And the 3 would get multiplied by 2 all the way across to get an equivalent equation. However, I am not done, because if I multiply now, I'll end up with 3 times 2x is positive 6x, and 2 times 3x is positive 6x. And I will not have a zero pair. I need one of them to be positive and one of them to be negative. So what I can do is change the sign of one of my factors all the way across to accommodate a zero pair. I can now multiply and write my new equations to the right. 3 times 2x is 6x. 3 times 4y is 12y. 3 times negative 4 is negative 12. In the bottom equation, negative 2 times 3x is negative 6x. Accomplishing my zero pair. Negative 2 times 5y is negative 10y. And a negative 2 times a negative 3 is positive 6. I can now add straight down and get an equation with one variable. 6x and negative 6x is 0. 12y and negative 10y is 2y. 12 negatives and 6 positives is 6 negatives. I can now divide by my y coefficient and get that the value of y is negative 3. Of course, I need to also have the value for x, so I'll need to work with one of the equations and substitute the value of y back in. I choose to work with the bottom equation this time. It does not matter whether I start with the top or the bottom. The values of x and y must be true for both equations. I will now substitute for my y value. So when I get to the point of writing the y the second time around, I'll write a parenthesis. I will substitute my y value into the parenthesis. I will now follow order of operations and multiply. And I will get it down to a two-step equation. 3x and negative 15 is equal to negative 3. Well, to zero pair the negative 15, I will add 15. I end up with the equation that 3x, 15 and negative 15 make a zero pair, is equal to 15 and negative 3, which is 12. I can now divide by my x coefficient and get the value that x is equal to 12 divided by 3 is 4. However, the value of x is 4 and y is negative 3 has to work in both equations. I will now check it in the top equation, recopying it as given. 2x and 4y is equal to negative 4. I will now write parentheses for my substitution. I will now be careful to substitute my values of x and y correctly. The x value being 4, the y value being negative 3. I will now follow my order of operations. 2 times 4 is 8. Positive 4 times negative 3 is negative 12. 8 and negative 12 make negative 4. And I get a true statement. So the value of 4 for x and negative 3 for y also works in the top. So I can write at this point that 4 for x, negative 3 for y as an ordered pair, 4 comma negative 3 is the solution.